Yali everyone. Welcome to our third webinar titled Engineering M2020. Thank you very much for joining us today. Great to see so many of you join us today. If this is your first time joining, my name is Ali Khan. I'm one of the organizers for Space Camp this year with Soraya, who will be introducing our speaker very shortly. I'm going to pass on to Soraya, who's going to introduce our speaker now.
Thanks, Ali. Hi, Space Explorers. I'm Soraya, and welcome to our third webinar. Welcome, everybody. And I am really excited to introduce Farah Alibay. Farah has a master's and a PhD in aerospace engineering from the University of Cambridge and the Massachusetts Institute of Technology. Farah is a systems engineer at NASA's Jet Propulsion Laboratory, and her latest project has been the Mars rover Perseverance, which some of you know was launched into space last month and due to land on Mars in February 21. So without further ado, I have the pleasure of handing you over to Farah.
Hi everyone. My name is Farah Alibay. I'm out here in LA, actually right here. It's the morning, so I'm just starting my day, and I work at the Jet Propulsion Lab, which is a NASA center out here. I've been in LA for 6 years now, and the mission I'm going to talk to you about today is the Mars 2020 mission, which is the Perseverance rover, and that is my second mission that I'm sending to Mars. Actually, I'm very lucky that I worked on a lander that went to Mars 2 years ago as well. But before I get started on all this engineering talk, and I want to talk to you a little bit, give you an insight into how these rovers are built and what we're going to do with them, I wanted to take a step back and just tell you a little bit about me and my journey. So I was born in Montreal in Canada. I'm actually French speaking. English is my second language. And I went to school in Quebec up until year 8. And then I moved to England in year 9. And so if you can imagine, I moved to Manchester and I didn't really speak English, and let alone having to deal with a Mancunian accent, and had to move to sort of a brand new school, wear a uniform, went to an all-girls school. It was all a very strange experience for me, but it was really great because I got to learn a new culture and make new friends and obviously learn a new language. So I did year 9 through 13 in Manchester, and then I went over to the University of Cambridge to do an aerospace degree. Now, when I was at Cambridge, I was mostly working on jet engines, which is still pretty cool, but I always had this dream growing up that I wanted to work in aerospace. And it started, honestly, I was born in the 90s, and if you're not familiar with the 90s, there were a few big movies back then, but Star Wars and Star Trek were very, very popular. I'm aware that they're still popular today. But I think those kind of made me dream about space. And there was another movie that came out in the 90s called Apollo 13. And if you haven't seen it and you like space, I would encourage you to go see it. It's the story of the Apollo 13 mission that tried to go to Mars. Apollo 11 landed, so this was one of the later missions. And there was an issue on their way to Mars, not Mars, the moon, sorry, I'm thinking about Mars. There was an issue on the way to the moon, and the engineers at NASA had to work together to rescue that mission and bring the astronauts back. And that particular movie had such a huge impact on me because I saw these engineers literally trying to fit a square peg in a round hole type of thing and having to work together as a team to figure out what was happening. So anyway, I always had this dream, and I had this opportunity to go do a PhD at MIT, and I took the leap. And the story there is that, I had a dream and I pursued it, and that was something that I really wanted to do. So I left my family and I took that risk, and I came over to the United States and started studying in Boston. And during that time, I got the opportunity to be an intern here at JPL. And that was such a great opportunity to get to experience what working here would be like. And that's actually how I ended up getting my job here. So the story there is that if you have a dream or you have something that you're really curious about, even at your age, it's okay to start being curious about things, start exploring, because eventually that could lead to a career where you absolutely love what you're doing every day. So speaking of, let me talk to you about the Mars 2020 mission. But before we talk about Mars 2020, I want to show you a little bit of the history of the missions that there have been at Mars. So if any of you are 17-year-old and under, so if you were born after 2003, one of the really cool things that I can tell you is that there has been a mission on the surface of Mars that we at JPLF talk to almost every single day since the day you were born. And that is pretty incredible to say that every day we talk to a rover or on another planet, and it drives around and it's exploring a completely other planet. And that hadn't been the case before, really. Before Spirit and Opportunity back in 2003, we had the Pathfinder mission, which was a tech demo. But other than that, we didn't really have rovers before then. So in 2012, actually, we landed the Curiosity rover, which is a car-sized rover. It's about the size of a Mini Cooper. And that was the biggest landing that we've had until the upcoming landing. And Curiosity has been looking for evidence of life. It's been doing geology and chemistry on the surface of Mars. And I was actually lucky enough to have been an intern when we landed Curiosity on Mars. And Curiosity is one of the reasons why I fell in love with Mars and JPL and robotic exploration, because it was really a big feat to land such a big rover on the surface of Mars. Now, as I told you, it's a little bit of a gap. And then in 2018, I worked on the InSight mission, which landed. InSight was a lander, did not have any wheels or anything. And it was studying the interior of Mars. And now over the next few years, there's actually going to be quite a few missions going to Mars. But most importantly, for me at least, the mission that I want to talk to you about is the Mars rover. One last thing I want to point out on this picture is all of these orbiters that we have around Mars. Often I get asked, how do you have all these images of the surface of Mars? How do you speak to the rovers on the surface of Mars? It's those satellites. So those satellites have radios, they can talk to Earth and they can talk to the rovers. And that's how we communicate with the rovers on the surface of Mars. So our rover is called Perseverance. We actually just got the name recently, a few months ago, and Perseverance, so there was a competition here in the United States to name the rover, and Perseverance was a name that was chosen. And I think it's a very apt name. You know, as you know, you've also been at home for a long time. And so we had to start working from home back in March. And so the team had to persevere through a lot of obstacles, not only because of COVID, but because of the complexity of building such a complex rover. So we're very proud of that name. But the Perseverance rover looks a little bit like the Curiosity rover that landed back in 2012. It's about Mini Cooper size. It's got 60 centimeters of clearance, but we have brand new wheels. We have a robotic arm up here that allows us to take samples, for example. And then the mast here has cameras, and it even has a laser up here to ablate rocks and to basically remove that layer on the top of a rock to look underneath and see what's there. So before I move on, I actually want to go over to Slido, and I'll kick off the first question. And it's a multi-choice question. And I want to know what you think the science goals for the Perseverance rover are. So you'll see a few options there. I'll give you a hint. There is more than one. So I'll swap over to Slido so we can look at what everyone thinks. So I'll give you like a minute or two to go through that. And it's interesting to see it all change. So it's pretty divided. Okay, so it looks like we kind of have a clear winner that most people think that the rover is looking for ancient life. And then We think the next step of finding water, studying rocks, collect soil samples, and prepare for human exploration. So actually, let's go over to the goals, and then I'll explain why I had these up. So I'll swap over to my other screen, and so most people are right that the main goal for Mars 2020 is to look for signs of microbial life. And so we're looking for signs of ancient life on Mars. So one of the cool things with Mars is that we know back in the day that it used to have an atmosphere and it used to have liquid water. And on Earth, places that have water have life. And so we think that maybe billions of years ago, there might have been life on Mars. Now, I'm not talking about little green, humans on Mars. We're talking about microbes, something really, really small. So I actually had a little trick in my question because I put as one of the possible answers, looking for water on Mars. We actually already know that there was water on Mars. That was one of our previous missions goals. So that was a little bit of a trick possible answer. We had previous missions that built on and looked for water. Now we know that there was water on Mars. That liquid water is gone. There's actually ice on Mars. But because we know that, we think that there might have been life. We are landing in a river delta. So we're landing at Jezero Crater, which is a lake, but there's a river going in and out of the lake. And when a river meets a lake, it forms a delta, and those deltas have a lot of sediments, have a lot of life on Earth. And so we think that there's a good chance that we might find evidence of life there if there ever has been any on Mars. And so the one thing that we'll be looking at is the geology. So whoever answered looking at rocks, well, you were right. That's what geology is, because we study the different types of rocks. We study them with their structure, and also rocks are possibly where we might find those building blocks for life. Astrobiology it's a little bit of a mouthful, but that is the concept of life outside of Earth. That's the field of study of science that looks for biology on other planets. That's why it's called astrobiology. And then for those of you that answered picking up samples, that is also one of our goals, because what we'll do is that we'll collect soil samples and then leave them on the surface of Mars and in a tube that will be sealed, and in multiple tubes that will be sealed. And the goal there is that we could eventually take these samples and bring them back to Earth. Now, why would we want to bring samples back to Earth? Well, the reason for that is because when we go to Mars, and I'll show you that in a second, we can bring instruments with us, right? Our scientists will ask questions and they'll bring instruments to measure different phenomena. But the thing is, if you ever work with scientists in the future, you'll find out that often when scientists ask themselves questions, they end up with even more questions. And there's only so much we can bring to Mars, and it's not like we can send more that easily. So being able to take interesting samples and then bring them back to Earth allows us, when we're here, to use whatever instruments we have available to test those samples. And then we can also build new instruments if we find something really interesting. And then finally, for those of you that said that we're preparing for humans, you were also right. One of the goals of Mars 2020, or the Perseverance rover, is to pave the way for eventually sending humans to Mars. And let me show you how we do that. So here is kind of like a blown out view of the rover, but what's highlighted in yellow is all of the instruments that we have on the rover. Now there's a few things that help us prepare for humans. So here, there's a weather station. So for people who said that we're going to be measuring the weather on Mars, well, we are. It's not one of our main goals, but we certainly are going to do that. We have a pressure sensor, a wind sensor. We can measure temperature. And that allows us, we actually do this on every mission, and it allows us to understand what the weather looks like on Mars. That's pretty important for anyone who might want to go to Mars later. Now, if you're thinking like, oh, I'd like to be an astronaut, I want to go to Mars, like that sounds great. I must warn you right now, it is not all that warm on Mars. If you thought that UK summers are cold, this is not fun. So the average temperature on Mars is about minus 50 degrees Celsius. Minus 50, minus 6, actually it's more closer to minus 60 degrees Celsius. A warm day on Mars is about -35, -40, and obviously it can get much colder than -60 on Mars. So not the warmest, not the most comfortable. Obviously there are spacesuits and you're pressurized, but it's still not the best environment to be in. Also, the Martian atmosphere only has about 1% of the atmosphere that the Earth does. So it's a really thin atmosphere that doesn't really protect you well from the sun. And obviously it doesn't have any oxygen. So if you were an astronaut that was going to go to Mars, you would either have to bring your own oxygen, which is a lot if you had to carry all of that, or you would have to make your own. Now we have an instrument on the rover called MOXIE, and that's exactly what MOXIE is doing. MOXIE is a technology demonstration, so it's not doing any science, but what it's doing is it's demonstrating that we can create oxygen on Mars. The way it does that is that it takes the atmosphere and then it extracts the oxygen from the atmosphere. Basically, there's compounds, there's molecules in the atmosphere, specifically carbon dioxide, which we have in the Earth atmosphere too. It's a type of gas, and they can take out oxygen from that molecule and store it. And so if we can demonstrate that MOXIE is able to produce oxygen from the atmosphere, then one day we could bring a bigger version of MOXIE, and that would allow us to create oxygen in situ, so in place for our astronauts. Now, MOXIE is only going to create about 1/6 of the amount of oxygen that you would need if you were going to bring astronauts to Mars. But the importance here is that we're demonstrating that we can do it, and that will allow us in the future to bring a bigger version. So other things on the rover, there's a radar here that can look below the surface. There's some cameras here. There's another instrument here that's a camera, but also has that laser that I was talking about that can shoot rocks and remove the upper surface of rocks. On our robotic arm, we have some other chemistry sensors. And then inside here is our sample caching unit, where we take those coring samples. We have a coring drill on our arm. It takes samples and then it puts them in the belly of the rover to be processed and imaged, and then we can drop them on the surface of Mars later. Okay, so I think my next question is a little bit of an easier one. It's also multiple choice. My next question is, how many cameras do you think there are on the rover? Looks like most people think there is either 5 or 15 or 16. Interesting. Let's see, I'll give it a few more seconds. Okay, so it looks like most people think, 16 is gaining momentum. Okay, I think that's about as many replies as we'll get. So it looks like it's a little bit of a tie between 5 and 16, and I'm sorry to say that the majority of you are wrong. We actually have 23 cameras on the rover, and I know it's pretty impressive, so only a few of you were right, but there's a reason why we bring so many cameras. So we actually have, when we land on Mars, we have a descent stage, so we'll have like a capsule and a parachute, and then this like jetpack that lowers us on the surface of Mars. And we're actually going to have upward-looking cameras that will show us the parachute deployments. We'll have a camera looking down on the ground, looking at the terrain, making sure that we're picking terrain that's safe to land on. We'll have another camera that's going to take video of our descent. On the rover here, we have cameras under the rover that allow us to see any obstacles that are there. There's cameras obviously on the head of the rover that allow us to see where we're going when we're driving, but also to take images, very precise images of our chemistry kit. There's actually cameras inside the rover to look at our sample tubes and to look at the type of samples we might have on there. But most importantly, we also have cameras on the robotic arm, and that allows us to take a selfie of the rover. It's not just why we have it, but it does allow us to do that. But it also allows us to take close-up pictures of the rover. So yeah, 23 cameras. That's actually the most we've put on on the rover before, but it'll allow us to really see Mars through the eyes of Perseverance. Because one of the things you have to understand is right now we don't have astronauts that are able to go to Mars. So Perseverance is our astronauts, and we see through the eyes of Perseverance. And that's why we need so many cameras. But in addition to being able to see through the eyes of Perseverance, there is also a microphone on the rover. There's actually a microphone on the descent stage and then a microphone on the head of the rover. So that's also a new feature. So not only will we be able to see Mars, but we'll be able to hear it. And we'll be able to hear the rover when it's driving. We'll be able to hear, that laser that I was talking about. You'll be able to hear the laser zap rocks, which I think is pretty cool. So that's also a new feature that we have on Perseverance. Okay, so let me tell you a little bit of like the timeline of what this mission looks like, just to give you an idea of how complex these missions are. So I told you that we were landing at Jezero Crater, which is in the northern hemisphere of Mars, and that target was chosen by our science team. So there's a team of scientists behind the missions, and they chose that target back in 2017. The rover design and build, actually the idea for the rover came in about 2012, 2013. It is a similar rover to the Curiosity rover, so we weren't starting from scratch. Think of it as like if you have a new model of a car or something like that. It's an upgrade, of course. But the build started back in 2014. So we had to build all the components and assemble them. The rover itself was fully assembled last summer, so about a year ago. And then we did a bunch of testing, which I'll talk to you about in a second. And in fact, as I'm telling you this, let me start my next poll, where I'm going to ask you what type of testing you think we did on the rover while after it was fully built. So I'll start that right now, and you can start putting your ideas there, and I will continue talking about what we did. Maybe that will give you some clues as I'm talking as to what type of testing we might have wanted to do before we launched for Mars. So anyway, we did all of that testing back last summer and through the fall. In February, we actually shipped the rover from here in LA, which is where we built it, out to Cape Canaveral in Florida, which is where it was launched. It was launched 2 weeks ago in Florida. So this milestone happened, and now we're currently on our way to Mars. And I haven't checked this morning, but I think we've traveled more than 10 million kilometers already. I think we're traveling, oh, it must be way more than that. I think we travel 1 to 2 million kilometers per day. Now that seems like a lot, but getting from Earth to Mars is about 500 million kilometers. That's 500 million kilometers that we have to travel. So we're going fast, but we still have a long way to go. It's actually going to take 7 months to get to Mars, and we will be landing on Mars on February 18, 2021. It's going to be a little bit late in the UK because it's landing at, it's landing at 12:30 p.m. in LA. So that's about 8:30 p.m. UK time. So you should put it in your calendars already. If you want to watch it, there'll be a live stream for sure. And when we land on Mars, you can see here, this is when we enter the atmosphere, we'll be in a capsule, and then we'll have a parachute. And then here you can see the jetpack that I was talking about. And that jetpack lowers us on the surface of Mars, and we'll actually land wheels down, ready to go. And we'll deploy our mast, this mast here, and we'll be ready to drive. So I'll actually be part of the team on day one, on the 18th of February, in the operations room, looking at the data coming back from the rover and starting the rover operations. So that's part of what my job will be. And so I'm really excited to be part of that surface operations team who'll be literally driving the rover on another planet. So let's go back to that then, to my questions that was asking what kind of tests do you think that we did on the rover after we stopped building it, but before we were able to launch it. And I'm going to swap over to Slido and see if anyone had any ideas. Okay, so let's see, the temperature, the capacity, temperature testing, see if all the instruments work, how quick the rover moves, whether it's staying straight so the balance is equal, testing the parachute, battery life. If you have questions, by the way, don't post them here because I won't be able to please post them in the question area so that I can answer them later. Testing on simulated terrain on Earth, navigation, signal strength, battery life, moving ability, ability to cut rocks. Test to see if it works properly. Check if it works. Yes, of course. Let's see, is that testing in this, or is this, if it's durable? Waterproof test we don't really have to worry about because there's no water anymore on Mars, and fireproof test not so much either because we don't really have fires on Mars. There's no oxygen, although certainly we don't. The suspension, yeah, these are all really great answers. So except from a few of them, we actually did most of those, and I'll show you a video of a lot of the testing that we had to do. So we actually do a series of tests, and I really like everyone that said about testing the environment and the pressure and the temperature, because that was one of my favorite tests. One of the things that we did is that we put the rover in a chamber that had where we could simulate the Mars temperature and atmosphere, and from there we were able to do some functional testing. So for those of you that said make sure if it works, so make sure that the instruments work, we call that functional testing, so knowing that we can do functions. So we did that in the Martian environment. The other really cool test that we did is that we put the rover in its landing configuration and we put it on a shake table and really, really shook it, because when we're launching, and especially when we're landing, there's a lot of shaking that happens. And so we want to make sure that it doesn't fall apart, right? That we don't have any loose screws, that everything is in place when we land. So let me show you a video and I'll talk you through what's happening there. And this is a video of the build of the rover. So this is part of what I did, and I was part of the team that was testing the rover when we were preparing last year. So here you're seeing the crew stage. It's being assembled. That right here, right here, that's the jetpack that I was talking about. Where we're doing things here like we can flip things and assemble them together. This is the room at NASA where we build everything. Here you see the rover being transported. It's really big, so it's quite the affair to transport things. This is the room I was talking about when I said that. Let me take it back a little bit. When I said that we were putting the rover in a special room that allow us to test the temperature and pressure of Mars, this is it. And we also have these lights up top that simulate the sun and the impacts of the sun on the rover. Here we're putting in the instruments. We're testing out all of our motors, making sure that we can deploy, that we can take images. This is how we build the wheels, by the way. Our wheels are metal, the aluminum. This is where we assembled and tested the suspension. So whoever said that, that's what happened there. Here we inspect everything, make sure that everything was assembled correctly. And then you'll see testing of, this is our power source that we're installing. So whoever talked about, oh, this is a couple of good ones. Whoever talked about testing the batteries, we did that. I think someone mentioned that we would practice drilling. Absolutely. We've taken hundreds and hundreds of samples with our drill. And then you'll finally see here at the end, we also test the robotic arm, make sure that it moves properly, make sure that everything fits together. So basically what we do is that we put the rover through a series of tests so that it's going to survive the environment that it's going to see at Mars, but also to make sure that it's going to achieve the goals that we want it to achieve. Now, someone also mentioned that we tested driving, and that we might have tested making sure that it goes straight, that it turns the right way. And that's a very good one, because I happen to work on the driving system for the rover. I work on the mobility team. And so one of the biggest tests that I was part of is that we actually drove the rover inside the clean room, this chamber that we have, to make sure that, that it could drive properly, that it could drive straight, that when I told it to go right, it would go right, that it could go up some slopes. So this test happened last December, just a little bit after my birthday. And this was the only time that we drove the rover on what we call this the dance floor. So you'll see that quite a few people came and watched us because they were really curious to see it drive. It's actually the only time that humans will see that rover drive, because the next time we drive is actually going to be on Mars. So we took it over some ramps, and you'll see we also made it do some twists. kind of a little dance to make sure that it was doing the right thing. And yeah, there's an entire team there because it's the first time that we were driving the rover. So we wanted to make sure that everything was going to go okay. Now, I've told you that this was the only time that we drove the rover, and that's true. So then what are we doing for the next 6 months, right? If we only can, oh, do we really test the rover just once? Absolutely not. So part of my team, part of my work as part of the mobility team is that we have to put the rover through a series of scenarios, right? And so we have something called the Mars Yard, and this is a picture of it, and it's out at JPL, and it's basically a big sandbox, and we build like different slopes and different environments. We have all these different rocks that we can place, and we build obstacle courses for our rover there, and we have 2 rovers that we can use to test on Earth. So one of them is this rover. It's called Scarecrow. Scarecrow has the same weight as Perseverance will have on Mars. So the gravity is lower on Mars. So we have to use a rover that has a lower mass here on Earth to be able to do our testing. We call it Scarecrow because it doesn't have a brain. It can only do driving. It can't do any of the science. But Scarecrow is the main rover that we use to do all of our mobility testing. And we also are able to do something called autonomous navigation. So our rover is actually self-driving. So, many of you might have seen or heard of self-driving cars here on Earth. Well, our rover can self-drive on Mars. And while, there's no other cars and there's no pedestrians to worry about, we also don't have GPS on Mars, and we don't have maps, we don't have roads. So the way that we self-drive on Mars is that the Perseverance actually takes images of the area in front of it, and it uses AI to find its own obstacles and decide the path that it's going to take. So our, Perseverance is pretty intelligent, but we test all of that software here on Earth in this sandbox. We also have a replica of Perseverance, a full replica that we also use for testing, and we test a lot of our other capabilities using that testing. So starting next month, for the next 3 or 4 months, that's what I'll be doing. I'll be out in the Mars Yard testing these different robots. Literally, my job is to play around with robots all day and make sure that they behave properly, which I gotta admit is pretty fun. So one last picture I wanted to show you, because I mentioned that I started at JPL as an intern, is this picture here. So on the left here is me back in 2012 when we landed Perseverance on Mars. And so when we landed Curiosity on Mars, which was the original big rover that we landed on Mars. And you can see here behind me is the replica of the Curiosity rover. And when I was an intern, it was really cool to see the team land this rover on Mars, this huge rover, change the way that we do engineering, change history, and do this incredible science. And I just thought, wow, I really want to be part of that team. Like, how incredible is it that they're changing our understanding of the solar system? We're doing these really cool engineering feats, and I was just really amazed by what was happening. And then on the right here is a picture of me about, maybe 6 months ago in the test bed. It was probably 2 a.m. after a long day of work. But you can see that I'm smiling and super happy, because for me, working on this mission, working on the Perseverance rover, which is the next big rover that's going to Mars, it's just come full circle. It's been a dream of mine, and I'm really looking forward to February 18, when we'll be landing on Mars and seeing those first images of Mars, because you have to imagine no one's seen those images before. So seeing that is going to be really exciting. So I want to leave you here with a few resources of places where you can learn more. So we have, NASA has some Twitter accounts and Facebook accounts. There's also the NASA JPL and the NASA YouTube that has some really, really great videos about the mission. You can also go to mars.nasa.gov/Mars 2020. There's some fact sheets on there and all sorts of tools to learn more about the mission. And so with that, I think I'm going to swap over to Slido and look at your questions.
Thank you. Thank you, Farah, so much. Wow, how lucky we are to hear this unique perspective of how the rover was built and tested from someone who has worked directly on it. So that's just an incredible insight. We have about 10 or 15 minutes for questions. So I'll hand back over to you, Farah.
Thank you, and I'll just work my way through. So if there's questions that I may not get through all 70 of them, so if there's questions that you think are interesting that you care about, upvote them so that I'll see them first and I'll answer them in order of popularity. So the first one, what is the approximate temperature at Mars? How much hotter or colder is it compared to Earth? I think I mentioned that already, but the average temperature on Mars is about minus 65 degrees Celsius. So depending on wherever you are on Earth, basically it's much colder than it is on Earth. And a warm day on Mars, like a warm summer day, is about minus 40 degrees Celsius. Now, I was born in Canada, in Quebec, and minus 40 was the coldest days of winter. So, so definitely much colder. I'll mark that as checked. How long does it take to get from Mars to Earth? So same as it does from Earth to Mars, it takes, if you were to travel there, it takes between 6 to 7 months typically to get one way on a one-way trip. And so to get on a round trip, it would take you over a year. What information will the rover get for you when on Mars? So I think I talked about that a little bit too, but we will be obviously taking a lot of pictures. We have the microphone. We will be taking samples, and then from there, we do some things called spectrometry, for example. So we do chemistry on them, get information on the composition. We'll get temperature of the area, pressure. We'll get imagery from radar imagery of what's below the surface. So really a varied set of information about Mars. What if something goes wrong with the machine? So I'm assuming you mean, what if something goes wrong when you're on Mars? And that's a really good question, because one of the challenges of my job is that the rover is all the way on Mars. And so if something goes wrong, we have to be prepared. So first off, we have what we call fall protection on board, which means that if anything goes wrong and if anything doesn't quite go right, the rover knows to stop. It's just not just going to keep driving, for example, if it ends up in an area where it doesn't think it's supposed to be. So it stops and it'll call home and it'll send us information, and then we have to debug here. But it's actually one of the most fun and hardest part of our job is that we have to debug with whatever we have available. And so, you know, it could be that we have to adapt, or we have to drive a certain way. For example, on one of the old rovers on I think it was on Opportunity, which was one of the Mars exploration rovers. Oh, maybe it was Spirit. It lost a wheel, and so we had to drive it backwards because there was no, roadside service there to change out the wheel. So that's how we deal with that. So so when things go wrong, we are as prepared as we can be, and we try and think through all of the issues that might happen. But of course, and then we have to use imagination and teamwork to figure out solutions. Okay, how do you clean the rover to ensure there's no bacteria from Earth and humans being transported to space, contaminating Mars with Earth life rather than Mars life? That is an excellent question. So there is something called planetary protection that dictates how much bacteria there can be on the rover, because yeah, that question is exactly on point. If we're looking for microbes on Mars and our rover is dirty and then we get there and we find something, we're never going to know if it's an Earth rover, if it's an Earth bacteria or a Mars bacteria. So you probably saw in my video that everyone was wearing those white bunny suits and those masks. That's not because of COVID. This was well before COVID. We actually have to wear those in the clean room to keep the rover clean. So it's not so much that we clean it, although we do clean surfaces that might have been touched, is that we keep it clean. And then every so often we will take samples of the surface of the rover and let them cure to see how much bacteria there is on there. Now, one thing in particular was those tubes that I was talking about those sample tubes that we want to bring back to Earth. Those not only have to seal so that nothing goes in, but we had to keep those extremely clean. And so those had to be kept so clean that we actually kept them separate until the very last minute. And we only put them in the rover at Cape Canaveral a few weeks before we launched to make sure that they were going to stay really, really clean. So that's why we do it. Another reason, by the way, that we want to keep the rover clean is that you don't want any dust or anything on there. So on your, on your iPhone camera, you might just choose to like wipe it off if there's a little bit of a dust speckle. You've all seen how bad the pictures look if you have fingerprints on there or anything. Well, on a rover, if there's a fingerprint or a piece of dust on our camera, that's it. You get bad pictures forever. So we have to make sure that those are clean too, not just for the bacteria, but also for our science and for those pictures. Okay. I have heard that the rover would take some samples from Mars. Yes. How many samples could it take and how long would it take to reach Earth? So I believe that we can take more than 20 samples, but the idea is that we would bring back 10 to 20 of them. So we would take a variety of samples. I can't remember exactly how many we're able to take. I know it's a lot. And then we will choose, okay, which ones do we want, which ones do we not want? And then eventually we will bring them back to Earth. Now, in order to bring them back to Earth, it's not this mission that will bring them back. We would have to have another mission that would land a rover, pick up the samples, put them on a small rocket, and then bring them back to Earth. So that is pretty complex. And so assuming, one step at a time, we'll see if we can collect the samples first. But assuming that we do and that Perseverance is successful, the hope is that we would bring them back to Earth possibly around 2030. So it's possible that, if there's something that some of you are interested in, you might even become part of the team that might bring those samples back, because it is a little bit further down the line. But once we launch the samples, it only takes about 6 months to get back to Earth. How long is a day on Mars? So that's actually a good question, and I'm going to tell you an anecdote related to that. So Mars, the Martian day, so a day is defined by the rotation of the Earth, the rotation of a planet, right? So a Martian day is called a Sol, S-O-L, and it is 24.5 hours. So it's just longer than an Earth day. Now remember that Mars is about 1/3 of the size of Earth, so it just rotates a lot more slowly. Now, one thing that's interesting regarding that, which I didn't really talk about, is the fact that when we operate our rovers, so I'll be part of the operation team, we actually work during the Martian night. So at about 6 p.m. Martian time, the rover sends us back all of this information, its pictures, everything it's done for the day, and sends them to Earth. So we come to work at around 6 p.m. Martian time. We look at all that data, we analyze it, and then based on that, we build a plan for the next day, and we literally just code up a plan for the rover to use, and we send that up to the rover at about 6 a.m. Martian time. Now that all looks fine, right? You think, okay, you're just coming into work every day at the same time on Mars, so it's just a time difference. But I just told you that a Martian day is 24.5 hours. So what that means is that even though we come into work at the same time on Mars every day, we actually come in to work on Earth a half hour later every day. So one day I might start at 9, then 9:30, then 10, then 10:30. So you can start to tell that it gets very difficult to figure out what day it is or what time of day it is. But thankfully, we only do that for the first 100 days. And after that, we go back to working every other day so that we can still operate the rover, but have a little bit of a normal life. That's this question. Why is Mars cold even though it's the closest planet to the sun? I think you need to maybe go back and study the planets a little bit. Mars is not the closest planet to the sun, it's Mercury. So it goes Mercury, Venus, Earth, and Mars. So Mars is further away from the sun, and that's why it's colder than Earth. And also remember that it doesn't have an atmosphere, and that's one of the things that keeps us warm on Earth. Can you breathe on Mars without a helmet? No, I think I explained that when I talked about MOXIE. There's only about 1% atmosphere, so about 1% of the Earth atmosphere on Mars, so the atmosphere is a lot thinner, and also there is no oxygen. Oxygen is what you need to breathe. And so that's why we're bringing MOXIE to demonstrate that we can make oxygen on Mars, and that will, allow us to eventually allow astronauts possibly to be able to breathe on Mars. Why did I want to be an astronaut? Well, okay, so that's a good question. I think I always dreamed of being an astronaut, possibly because of those movies. And there was also an astronaut growing up called Alibay, who was French Canadian like me, and I was really impressed by her. But I think my dream, and I still want to be an astronaut. Working at JPL is not a bad backup job. Yeah, so I think I just always wanted to be an astronaut because one of my dreams is to look back at Earth and see the Earth as a whole. But also, I think I'm an explorer by nature. I'm really fascinated with answering questions of who are we, why is Mars different, where do we come from, and being an astronaut does that. But I'm pretty lucky that I get to be an explorer through the eyes of these rovers that I work on, and I get to see pictures every day of new areas on Mars that no one's ever been before, and so that's really cool to me to be able to see that. So that's why I want to be an astronaut. I want to discover, I want to do new things, and part of me just wants to go to space and experience what weightlessness would look like, and what Earth might look like, and what it takes to live in that different environment. I find that really fascinating. Okay, let's see. Have we covered the whole diameter or radius of Mars? No, absolutely not. We've done we've done exploration from the satellites above the surface of Mars, and we've definitely reconstructed. We had imagery of the entire surface of Mars. Like the whole thing has been imaged multiple times, but we have not actually driven the entirety of it because we actually can't drive that fast. Even our rover that has self-driving capability and is going to drive faster than any other rover ever has done before can only really cover about 200 meters per day. And so that's not, it's not very much, right? It's very fast for what we can do because we have to build the maps, we have to go over our obstacles, but it's definitely not enough to cover the entire radius of Mars. Can you take a person to Mars? Not yet. I think I talked about that. What is the link for watching the launch of the rover on the 18th of February? Go to the NASA or the NASA JPL YouTube page. You can follow them and it will be on YouTube for sure. I just answered this question.
Farah, I'm just going to interrupt there. I think we've got time for one more question.
Okay. Let's do this one. What path did you take to become a NASA engineer? And I think I talked about that a little bit, but I want to explain something a little bit more. So I talked about the fact that I did internships and that's how I got my job. But one thing you have to remember, and this will be true in your life, no matter what job it is that you want to do, that there's going to be obstacles around the way. There are people that told me that I shouldn't be an engineer because women didn't belong there. There was pressure for me to be a doctor because that's what everyone was doing in my community, and because I was smart, and people thought that's a better career, right? And that my dream was always to work at NASA, and I don't remember how many internships I applied for and how many times I was told no. But the one thing I can tell you is that we only really need one yes. You only need a few people to open doors for you in order to achieve your dreams and in order to enjoy your job as much as I do. So if you take anything away from this talk, just remember that if you have a dream and you have something you want to do, then go for it with your full heart in it. Give it everything you have, which is what I did, and don't get put off by the people who say no every time that you fail at something. Just try and keep trying because it's worth it at the end if you can live your dream essentially. So I think that's a good note to end on.
Thank you so much, Farah. That was a really nice way to end the webinar as well. Really kind of inspirational note for a lot of our participants, I'm sure. So that last question brings us to a close today. I want to thank everyone for coming today and behaving really well throughout the webinar, and listening to Farah talk about how she helped to build the Mars rover and a little bit about her career path.